Well, hopefully everybody stretched their legs a little bit. What a great conference. Thank you again for the opportunity to speak again. We're going to kind of expand on what we did yesterday, Brenda and I. We didn't add the shredded wheats, though, so Brenda's a little more creative. I didn't get quite that creative, so I apologize. But we're going to kind of tag team it again here today. We're going to make it a little bit less informal. I guess I can take my mask off to begin with. That sounds a little better. And what we want to talk about today, a little bit different, is kind of where we're going to go. What's the next generation of stormwater management? We had a lot of great examples this morning. We're going to kind of build on those. We're not going to have the time to take a deeper dive into a lot of these. We're going to kind of give you some sampling of what Brenda and I have worked on, some different clients, kind of how that next generation is starting to look like for stormwater management. So with that, I talk a lot with our younger engineers, with clients, this analogy, right? Get outside that box. How can we start being more creative? And in preparing for this conference, I've started to do a lot with what's the value of the stormwater infrastructure? Have we ever really thought about that? How can we increase that value? That's really what we're tasked with trying to do for the public, right? Of trying to increase that value of stormwater infrastructure. We're going to talk quite a bit about that at the beginning of this presentation. And then Brenda and myself, but Brenda will focus a little bit more on kind of that balance, right? We have to balance between our development needs, our community needs. How do we really do that in stormwater management? We'll talk a little bit along the way about some smarter technologies, how we can integrate technology with stormwater. And then, Brenda and I are real big, and many of our sidebar conversations with all of you here today, why are we doing this? Did we do it in the way in the past? And what are some reasonings, and how can we explain that why to our elected officials of why we need to change? And that's a big step, and I know we're all really, it's a challenge for all of us, that why do we need to make stormwater better, right? And so we'll talk a little bit about that at the end. Okay, so I'm going to start here with kind of a pictorial tour. Sometimes a lot of our stormwater infrastructure is out of mind and out of place. This is what we're all talking about. We have a lot of stormwater infrastructure out of there. A lot of it's out of sight. A lot of it's large pipe. A lot of that large pipe, unfortunately, could be corrugated metal pipe that's decaying. There's a lot of infrastructure in the ground in our cities across the country related to stormwater. We also have open channels or streams. I use this slide to hopefully illustrate pretty clearly the issues of environmental justice. These two streams, creeks, are in Kansas City, Missouri. The one on the right is near the most valuable property in Kansas City. That is the plaza. The ditch on the left is Town Fork Creek. That is a quarter of a mile away from the picture on the right. Some of the lowest property values in Kansas City, Missouri are along Town Fork Creek. That's actually the creek I showed you the other day that the bottom of the channel failed. It was just a very poorly done trapezoid concrete channel. So that's, to me, a really stark difference between how have we invested in some of these neighborhoods. Completely different when we look at stormwater management. As we look for the next generation, I know in many of the cities, including Kansas City I'm working in, environmental justice, where we're investing in stormwater is a real driver for community reinvestment, right? And so these are things we need to think about for the next generation.
Yeah, so our stormwater infrastructure is not just limited to the pipes and inlets that Andy just showed. Think about all the bridges and culverts that are out there too. This picture on the left shows we put in that double box culvert so that our road could go over the top. But look how the stream has corrected itself. It's not the same width as that double box. So maybe we graded this out at one point, but it's correcting itself now and filling back into the width it wants to be. Or you have other cases like the one on the right-hand side where we've paved it in. So now that paved channel is another piece of infrastructure that we have to maintain over time. And a lot of these are falling apart where they were built, say, in the late 70s, early 80s.
Right. And the thing here too, what value, once again, are we getting out of that? If we're going to have the expense of putting in a double box and Mother Nature wants to put it back and sediment in, what's the value again 20 years later? How can we maintain that value for a longer period?
Or the different types of detention and retention that we're seeing are changing. So we're used to the system up at the top left here, where it's a detention basin and maybe even has a low flow channel. So it's bypassing the detention basin. We see these a lot. Or, a retention pond. We've seen a lot of those over the years too. More of our systems are going underground, and that's depicted on the top right before that system's covered up. So are we keeping track of these systems? Do we know where they're at? I think that's going to be very important as they are going to be critical pieces in our redevelopment over time, where there's not space to do larger stormwater management practices. Other examples of what this can look like. The example on the right, we talked about different ways to collect trash in our stormwater systems before you convey to a wet pond. This is one of those types of facilities. The baskets have to be cleaned out though, or this doesn't work, right? We have to retain the function of this piece of infrastructure. We did monitoring at bioretention cells, that's shown in the bottom picture during a rain event. And then the top left is a boulevard area where they're trying to collect more of the water in the depressed area of the medians versus it running off to the streets.
Yeah, all this is infrastructure, stormwater infrastructure.
Yeah.
And then unfortunately, some of our stormwater infrastructure doesn't look very pretty, right? We've seen some of these pictures before. It can impact the quality of our ponds. It can impact our streams, our ditch sections. All this are challenges and things we need to build on. So that's kind of our pictorial tour to get started here today. What I want to talk about now you just have that visual of all this infrastructure that's out there, is what I want to challenge us with now is, what's that value, what's that function we're providing to the public? Well, coming out of World War II in the 50s and 60s, what did stormwater infrastructure need to do? What was the value we were putting on it? It was conveyance, right? If anybody's taken an open channel hydraulics class, it's a trapezoid channel. If we put concrete it, we lower the mannings in, we can get a very efficient channel. We did a lot of this type of work in the 60s and 70s. That's the main function. Then we started to get into things where we wanted to store it. We wanted to have more retention, detention. So we provided detention ponds, retention ponds. That's a value, right? We're putting on that. And then in some cases we started to do more recharge type subsurface, retain the water long enough so we can infiltrate and those types of things. So we're trying to build, we're adding more value, right? But if we start to think about then, you begin our NPDES programs, now we're doing stormwater treatment. So once again, we're building that value. But I would also say there's other things we can do. The Walmart example is a great example. Can we reuse that water, retain that water for reuse for irrigation? I mentioned the city of Lenexa, Kansas did a range recreation project. What they were trying to do is link that to what recreational value can I get out of my stormwater management. But then if we really get out of our side of our box, what are other multiple functions? Can your parking lot be a stormwater management facility? Can your street? There's some vendors out there we've worked at that, with different pervious pavements, we can start to make a street a stormwater management facility, right? I mean, these are out-of-the-box ideas, but we're adding value to all these, right? And then finally, that mimic, we had a great tour yesterday afternoon. And to me, that is getting back to how can we mimic that Mother Nature, make it a watershed, wildlife habitat, all those things. But as we go down this list, can your stormwater management in the future do all these things? That's where we get that increased value, right? So I was flipping through a journal, and my kids make fun of me because I'm kind of a nerdy person of looking at how we can explain things differently. And I came across just a basic economic little study, and they said, well, this value statement, right? So cost is on the y-axis and value is on the right. And what they talked about in this article is you can divide this basically into 4 quadrants, right? And so any type of infrastructure, any type of improvement you're doing, you have kind of these 4 quadrants that you can fall in, right? We can have low cost, low value, What does that look like in stormwater? I see a lot of this out there, right? Hodgepodge of, we do the lowest cost thing we can do, and I got a city engineer sitting over here, and I mean, those are things that just happen, right? It's, you have a certain budget, this is what I can get in to help solve the problem, right? Or in some cases, you can have a higher cost, low value. This is a 84-inch Hobos pipe that's been jacked into a 84-inch corrugated metal pipe that goes under a major road in Kansas City, Missouri. Very high cost, low value. It's done because the road's going to collapse and we got to do it. By the way, this is also an over $1 million change order and the shoring it took to be able to get the construction workers down in that hole. High cost, very limited value, right? We're just conveying water underneath an existing street. But then we look over here with a lower cost, high value. At happy hour yesterday, I talked a little bit about this at my table. This is a small town in Missouri, Fulton, Missouri, where the city administrator said there's no way to solve this problem. It was too expensive. And I said to Bill, I said, why do we only have to convey it? You own this parking lot. This is a picture of a parking lot. We use our tanks, plastic tanks. He has 2.5 acres of impervious area that was draining out to the street that he only had a 18-inch pipe. He thought he needed to make a bigger pipe. I said, why don't we take your parking lot and put it into your stormwater management, and we use pervious pavement on top of it, which he didn't believe would work, so he tried to go out and flood it with 2 fire trucks. Couldn't flood it, by the way. But anyway, they did this with city crews, and this was a $32,000 solution. That was the material cost. Of course, the city labor, it was more than that. It took the city crews about 2 weeks to do this project. But a $32,000 cost to him, because he already had the labor, we solved the problem. So there, that's a lower cost, higher value, right? And then finally, what we saw out here last night, what Brenda and I have been working on some of these projects, how can we get that? It's a little bit higher cost, but it's a much higher value. Now here's the thing that I see in stormwater that we all have to admit to, is some of the things we've done since the 70s actually have a very negative value to the public. And I think when you think about some of the areas in the Illinois River watershed, this is some of the things that you see out there, right? We actually have these low-cost items that are causing a negative value, unfortunately. I showed this picture the other day where a simple extension of a large culvert has ripped this stream apart. Or the high-cost negative value is some of our enclosed systems now that we've connected more impervious area to the top end of them. Actually, this is in Kansas City, Missouri again, during a 2-inch rainstorm where you're actually getting basically a geyser because you have this large enclosed system, a very high negative value, but a very high cost, right? So with that, what are we trying to do? We don't want to do those things. What we're trying to do is move ourselves along this curve, right? How do we get from here over to there? That's really what my challenge is for you guys here today. That's the next generation. That's where we want to get to. It's not going to be easy, but we want to get to things that have that higher value. And so we'll talk a little bit how we get there in these next slides.
Yeah, so looking for opportunities to, again, create that balance. And we started to talk about that yesterday, too. Where are there opportunities where we can layer in stormwater management to other things we want to do on the site? And I think it was Carol had asked, how do we start to make some of these changes? And I think it's really in the way we start to look at a site. So it's designing together as an interdisciplinary team versus in each one of our silos. So are there opportunities where we can start to increase the value of our existing detention basins? And I know that's a lot of the feedback that I've heard from this group when we've gathered is we have a lot of detention basins that aren't working. Is there a way we can get them working better? Maybe it's retrofitting them with a new outlet structure that controls a range of storm events. Or we're going to talk a little bit about what if we start to automate some of that control? We heard a lot about this yesterday, where pipes are being constructed to bypass a lawn area or bypass green space. Are there opportunities where our green space can be more than lawns? And looking for those opportunities even as a retrofit scenario. collection being more than inlets. I thought it was great to hear that being applied in the Walmart project example that we heard about this morning. So many opportunities to collect stormwater in different ways and have vegetation that uses that stormwater. Conveyance. So we talked a little bit about this yesterday too. We're never going to get rid of our enclosed systems completely, nor are we advocating that. It needs to be a combination of both. So you may have more opportunities for grass swales like that are shown on the left that are being used in a parking lot situation, or this is more of a cascade that was constructed on the right to bring water from an enclosed system down through a park setting. Parking lots, lots of opportunities here, whether it's building in median areas or using the parking spaces themselves, depending on the area you're in. This can be ways to reduce your impervious area, or you can build storage underneath it potentially. And a lot of different materials you can use on the surface. A lot of different products out there. Concrete and asphalt are also options as well. So multitude of options there. That can also be applied to like driveway settings too. So you'll see an application on the right where a product was used that also is providing storage underneath in a very highly impervious setting. This is also in a very highly trafficked area where they're bringing in deliveries, trash trucks. Also, it's a juvenile center, so there's a lot of traffic in and out for inmates. Do you want to talk any about the?
I think I already covered
you
the
covered that?
Fulton
Okay.
one. The only thing I'll say about pervious pavements too, we've talked a lot about maintenance, is we've been doing monitoring of pervious pavements, and some of these do degrade pretty quickly on the infiltration rates. So like anything, I think we need to also be prepared that these types of facilities do need maintenance. You do need to vac these out typically to restore that infiltration capacity. So they're not just install them and walk away for 15 years. You're going to have to maintain these facilities to make them function. And the final couple here, is these are kind of the projects, of course, that Brenda and I get excited about, and you guys here in the audience get excited about, is how do we take some of these larger open spaces, these parks that may not be fully utilized, and turn them into something that, once again, has that higher multiple value, multiple function to the public. This was a park that was severely underused, and bringing the public back to it with trails and making it an experience, not just a monoculture of open lawn that wasn't being used for really anything except being mowed. And then the final one, this is in Omaha, Nebraska. This is North Omaha. This was a large park area. When I first looked at it, there were 3 baseball fields here, and I thought the parks director would never want to do this, but they actually had a master plan with the community around it, and the community wanted a kind of similar to what we have out here, a larger park setting, and this is a 5-acre wetland complex that also provides 100-year flood protection for the downstream community that was in the 100-year floodplain. So there are opportunities in these highly urbanized areas. This is just north of downtown Omaha. There are areas out there that we can find these opportunities to, once again, stack those benefits and increase the value of our stormwater management systems. So let's just talk a little bit about some smarter solutions. I won't go into this a whole lot, but since it was mentioned this morning by Ted, this is, I've done a lot of work with, this is RTC out of Boston, a really interesting company that's using cloud-based technology and the NOAA forecasting to, in real time, open and close a valve. So it's trying to predict in real time, every couple minutes, what the NOAA forecast is going to do, and then it's going to open and control a valve so that we can maximize the retention in these existing facilities. And so here it is, looked kind of pictorially is what it's doing. So in a typical wet pond here, you get runoff in this pipe leading out of it would, after the rain stops, right, the water goes down to where the pipe invert's at. So it's a passive system. It just drains out based on the hydraulics of the pipe. But what if we went in there and we put a valve on that pipe, and we put controls to that valve, and then we monitor the water level in in the pond so we know how much volume we have, and then if we monitor the rain forecast, and this is what Opti basically provides in the cloud, it's automatic. There's no operator here except the computer has logic to it, and you enter that logic based on the NOAA weather forecast, it operates that valve. So it keeps that valve closed now because it knows the rain event's over. I can maximize my retention, right? And what that looks like on a couple sites that we've worked on is basically this is an 8-inch valve that has a solenoid on top of it with an actuator, and then a solar panel gives it energy with some marine batteries, and it has cellular technology that communicates both ways, basically from the control panel. And this is the facility looking upstream. This was a 2-acre dry detention pond in a very highly industrial area that wasn't getting much value again. By retrofitting this with Opti, what the results that we got out of this is what the dashboard looks like. It's all online. It's very user-friendly, but the results, which is very interesting, especially when you have back-to-back events, is that what Opti is doing in real time is that, so the first event was 1.32 inches. It only drained down the pond just enough, so the red line there, the dotted line, is the maximum retention we can get, or detention. And so it drew it down just enough, so we're trying to maximize that facility. And so in this case, we had almost 100% capture. We only drained down a little bit in between the two events. On an annual basis, this is what we're seeing. In 2017 into 2018, we controlled 98% of all runoff volume. This is just a retrofit. This is a less than $100,000 retrofit. Once again, increasing that value. In 2018, we had total retention of almost 90%, 88%, and we increased the retention time for water quality benefits by almost 40 hours of everything that's being held. So once again, it's a way to quickly kind of increase that value of an existing system. A lot of dry detention facilities out there. If you're a city official, those are some pretty low-hanging fruits. If you can just think about how can I either use technology like this or even retrofit them with different types of outlet structures to increase that value. So I'm getting more stormwater capture.
I think to add on to what Andy said on that last one too, another impact of that facility now holding water is we've been monitoring the vegetation in that facility, and we're working with a landscape architect to do that, and she's noticing very diverse species. It's back to what she would expect for the type of vegetation in that facility, which has been pretty interesting. So.
Yeah, it's really turned into like this wetland meadow. It's been really cool to see it kind of transposed just with the introduction of a lot more water over time. We're getting different species in there.
So as we look at infrastructure of the future, a lot of this is going to be retrofit situations, or we need to think about our redevelopment areas. We can't depend on just including green infrastructure and other practices on our new development. So one way we can look at this is through thinking about our infrastructure in zones of a watershed. So what makes sense in, say, the lower zone of your watershed, which is shown in that light blue here. To me, this is a place where I'm going to try to preserve that area, set it back. Even if I get that opportunity in redevelopment, I don't want to build a building necessarily in this area. It's typically where my natural waterway is or once was. We've got a middle zone. So that's the in-between blue, a little bit darker blue here. This is where we are typically seeing our enclosed systems. They began at this point, maybe a few open channels. These are typically the part of our watersheds that are very disconnected. So we've lost that link between our middle zone and our lower zone in our urban areas today. Are there opportunities for reconnection of those, or even to do more regional efforts for detention or retention? And then finally, when you get to the upper zone of a watershed, this is really our opportunity to catch our rainfall before we get it into those enclosed systems. So catch it where it falls. I know we talked a little bit about that. I think it was Martin yesterday, talking about how we're capturing that rain at the top of the watershed and the difference that that's starting to make throughout the Illinois River. These are really our opportunities, I think, in our redevelopment scenarios. So what can this look like? On the right side, we took one of the sub-watersheds within this larger watershed and started to dive in and to see what stormwater infrastructure could look like through these watershed zones. So I'll move from the bottom to the top. So we've got our upper zone. We are defining some enclosed system that we need just to help us route the water along the overland flow paths to capture it. It's a very urban area. But we've also got a mix of different detention practices and retention practices. As we move into that middle zone, we have an opportunity for more of a green street type scenario where they can define parking areas through maybe some type of pervious pavement is what they're looking at. But we also have a unique situation where there's an existing pond in the middle of the sub-watershed. And it's actually in the perfect area for a retrofit situation where we can bring stormwater there and use it. Now, as we move into that lower portion, it gets pretty interesting because our flow paths kind of congregate together. And this is where there's some redevelopment opportunities. So if we dive in here a little bit, this is looking just at that lower zone. I've overlaid those overland flow paths with what I would typically apply as a setback. So more of a traditional stream setback. So if I had room, this is what I would want. I wouldn't want to develop in this area. You'll see there's parcels outlined there. So this is an existing residential area. If I start to overlay the data that I have, just that city data that's out there, these are all of the land bank properties that are currently not owned by a private landholder. So
it's a very disinvested neighborhood here we're talking about. So a lot of vacancies. And so trying to say, you know, if we want to redevelop this, what's a better way to do it, basically, is what we're looking at here. So once again, use that opportunity for vacant lots as an opportunity to how can we bring stormwater management back in here, something that makes a higher value to this community.
And when you start to look at the vacant and the land bank lots, to me, I'm like, well, maybe one of the reasons these are vacant is because they were flooding at some point in time. The water was moving over the land and didn't have anywhere to go. The community really wants trails in this area too. And ultimately, they're trying to provide a connection, and they're thinking trails, to a creek, an existing creek, Jersey Creek, that's shown at the top right. But notice we don't have a path for the water to get to Jersey Creek right now either. So that's a problem. We have a whole sub-watershed that can't even get to the creek. So that becomes a huge goal when we're looking at potentially how could we redevelop this area. First and foremost, we got to get water to the creek somehow. And then is there a way we could reestablish that disconnected overland drainage that we're seeing? So we started to identify that we wanted to make what's outlined in yellow as our stormwater management area. So that would be the area we would be looking at stormwater first and redeveloping around that area. So taking all those off, this is what that could look like, okay? So you can see where we could look at doing a proposed even open channel, connecting that with some culverts where we need road crossings, and ultimately getting that channel to Jersey Creek. We can integrate trails with this new connection that starts to provide connectivity for the neighborhood. They could use this potentially as a pocket park or add a trail to get to Jersey Creek, and then look at trails to move upstream even in the watershed. As we move through here too, the other important thing that the client wanted to look at was how does this impact existing infrastructure in the sub-watershed? So there's existing street systems, there's a lot of old inlets, old manholes, old systems that aren't being used because there is so much vacancy in the area. So there is opportunities to remove some of that pavement, take some of that impervious area off, and take out some of the infrastructure that's not functioning. And then ultimately, we can redevelop in all those vacant areas that are yellow and kind of use that bright yellow greenway area as our focal point to develop around. And so this is something to keep in mind as you're starting to redevelop. Look at the bigger picture, zoom out, see what's going on in the area. Are there opportunities to combine parcels? And maybe there's reasons those parcels are vacant.
Right, so I was thinking about this, so why don't we do more of this, right? Well, stole the thunder.
Sorry, I clicked the button.
No, just kidding. A lot of it that I've been working with, and I know people in this room are working on this, what are our design standards? What are our criteria? Right now, a lot of our design criteria, unfortunately, they're barriers to some of the stuff that we just showed you here today. So how do we start to update those standards? Well, first of all, we need to know why were those standards developed. And if you don't know why, a lot of the stormwater design standards really came out of the Corps of Engineers Civil Works, right? And so cities have adopted those as a way to, like I mentioned, with these rainfall patterns and intensities, we tend to over-design with the conservatism that a Corps of Engineers should be designing for, but they're designing levees and dams. Once again, we're designing pipe systems. Do we need to have that same level of conservatism in there? Or are there better ways to maybe right-size our pipes? Those objectives before were more about routing water, right? These old design standards were more about peak flow, mitigating risk upstream to downstream. And typically it's more one size fits all. A lot of stormwater standards, there's not a lot of flexibility, right? You're doing that. So we need to think a little outside the box if we want to improve that. And that means updating standards. It also means that we need to, and I know this is a crazy idea sometimes for people, but we're only focusing on those large, less frequent events. And by doing that, we've painted ourselves in a corner to really have less creativity. We're really looking at, large pipes, but does that provide the value, right? Well, they're not controlling any of the smaller events. Like I mentioned, the streams are all seeing all those small events, and we'll talk a little bit about this in a second. We're trying to, reduce total infrastructure value. We're designing only to those larger events. So that's one of the things we need to be doing. And then I'll let you do this one.
Okay. Education, I think, is a huge piece of this puzzle. A lot of times we think that just putting out that one training and having that available online, that meets the education need. We need to understand why we do the design the way we do. And I think it's important for the general public to understand this too. Because again, if we understand why, we're more likely to be open to change and to look at what infrastructure could be versus what it is today. And it's hard. I didn't know if the mini wheats thing would work yesterday, guys. I didn't know, and maybe it didn't. But we've seen it referenced a few times through the conference. And it's making communication and education intentional and trying new things and to keep trying. All right. Ultimately, I think we need our infrastructure, and this is not just stormwater infrastructure. It's figuring out that balance between the performance and the cost. So think about this in all the infrastructure that we design and build. We got to figure out the increase to community benefit long term, and that's with redevelopment also. Those are our opportunities because we're not going to touch that infrastructure for probably another 50 to 100 years. Importantly, we need to integrate our natural systems, not just take them away. And then figuring out what is a resilient, holistic solution. And I think that is becoming more obvious that we need to get away from just checking the box on a design standard to promote this. We have to get our designers thinking holistically about a site. Stormwater specifically, we've got to reduce those downstream impacts. We talked about that a lot yesterday, and we saw some great example pictures of what that's doing right now. And I think we really have to get away from the notion that with stormwater, we're just capturing and then conveying. We have to put in an element of control in everything that we're designing and building right now.
So in conclusion here, we have a few slides to kind of walk through our process here or where we need to go to. And part of that we've talked about, and I'm going to kind of go through these quickly because I know lunch is almost here and you guys are probably getting hungry, but looking at multiple different events, not just one event, I think is important. Thinking about how that impacts your costs, especially on the amount of gray you need to be having. I think it's important to look at not only design event storms through Atlas 14, which I'll talk a little bit about here, but also this is Bentonville's rainfall data for the last 36 years of 1 hour total rain. And I know you get those larger events, but a lot of the events, 90 to 95% of the events for 1 hour totals are 1.4 to 1.8 inches. And so are we really developing infrastructure that's really, maximizing on that knee of that curve of actual rainfall? So there's that balance there again I think we need to think about. We also need to impact, how do those standards impact us? And this is kind of, once again, a very simple example, but hopefully it's a way to educate. This is what we're saying when we just do one rational calculation with one intensity, right? This is what we're supposed to be paying for. I want an 18-inch pipe because it's going to be flowing this full, right? Have you ever thought about what it's doing when it's not full? And this is 80, 90% of the time. When I get a ½ inch of rain and it only rains an inch an hour, that 18-inch pipe that I pay for, I'm using very little of it, right? I only have 4 inches of water in it, okay? If I double the rainfall intensity and the volume, I still only have about 6 inches in it. And if I double things again, as far as the volume, it's only half full. And so what I'm saying here is when we do design standards, this gets back to, could we design to the median value and maximize use of this pipe more? Because I'm reserving a lot of space in this pipe for a very intense event that may happen later. And if we think about this in a systems evaluation, is that the best solution, is all I'm saying here. And then the existing stormwater detention. I have a whole other presentation on detention. I'll get on my soapbox here for just 2 minutes. I see a lot of these detention facilities, and here's my challenge to everybody that has dry detention facilities in your neighborhoods. If you can mow your dry detention facility, it's not working properly. You're not getting much value out of that. Because we put in concrete aprons to make sure we route the flows right through it, right? And so what we're paying for is the hydrograph down below. We have a CFS in this case coming into this facility for a 10-year event of 130 CFS, and it's supposed to knock that peak off down to 53 CFS. What happens when it actually rains? This is the flooding event that happened that we mentioned the other day in Kansas City. The blue line is how it actually functions. So it only reduced the peak flow of this actual event 4.2%. This is a 10-year, this is a very large event. If we retrofit this, I can get almost 40% by adding something like Opti or something else. So I've now increased that value for that facility. So think about your detention facilities that are out there. Are they functioning like that hypothetical design event? Are you getting full value out of that, is what I'm saying here. We can do, models have come a long way. A lot of cities have detailed LiDAR. I've been doing a lot more 2D continuous simulation models. Really starts for you to understand the enclosed system as well as the overland flow path. This particular watershed, we were able to reduce the overall cost of this project by $11 million by doing some continuous 2D modeling, because we right-sided the pipe and we reconnected overland flow paths for those larger events. And instead of a $40 million solution, this is now budgeted at less than $30 million, $28 million basically. So these larger infrastructure projects, take the time, make the investment. With 2D modeling does help you extensively, because a lot of stormwater issues are not 1D. We have pipe flow going that way and overland flow might be going that way. And you really need to understand that in these urban systems. And then finally, I'll turn it back over to Brenda here, I think, in a second. NOAA Atlas 14 has some great resources in there. Don't just look at the 10% or they're giving you all these frequencies, all these probabilities. Use this as a resource to look at what fits my community and my level of service. It's not just has to be one. So on that top graph, like I mentioned yesterday, that's the first quartile. The first quartile is where they have more data on. These are 6-hour durations. They'll give you the 90% probability, which is the green line, or the 10%. 10% is typically where we're designing larger flood control. What if I want to use the median value? That's the purple line. Maybe that makes my pipe size a little bit smaller. Maybe I can then reduce my cost by not reducing my level of service. Think about those types of things when you're using Atlas 14. There's a lot of information in there. A great way to get your standards updated using a national reference like this.
So I think if we're going to start looking at standards and revising, we need to understand the limitations of our existing toolbox. This is something I'm passionate about because a lot of times I see very complicated requirements for what's required as a designer for me to submit just to put an inlet in. And I know that there's no model out there that actually models an inlet, and I know what each one of these variables is now doing. And every time I do this, I'm like, why am I doing this? I know I probably just need an inlet about every half block or an inlet every half block at a sump area. So I think it's starting to balance some of these, some of our older toolboxes with all the data and information we have today, those observations. We need to consider the reality. Oh, went the wrong way. Let's go this way. Back to the education, communication. This needs to be intentional and with everyone that is working on a project. So a couple aspects to this. We have some great design manuals out there that get us through those design plans. We need to make sure we have the tools out there that the contractor can actually take those design plans and build it. Does he have all the information needed to actually build what you have on the design plans, the specifications? Are the materials available in your area to build what you need to build? Also, it's not just about holding one pre-construction meeting, okay? I see this a lot. They're like, okay, Brenda, you designed this. You need to be at the pre-construction meeting to tell the contractor all about this design. Okay. Then I get a call, okay, Brenda, you need to come out on site. Because these folks that were down there installing this tree planter weren't at the pre-construction meeting, right? So communication is ongoing, and I think we need to incorporate our designers throughout that construction process too, to be communicating with the folks that are actually putting in the material. In this case, once they understood the function, what we were building here, they wanted to do everything to protect these facilities and build it right. This is actually a structural soil that they were putting in. We had thunderheads rolling in to the west. We knew it was going to rain. So we scurried around on the site to protect these. They knew it was important to protect them or they were going to have to take out all this material that they had just placed. They protected them. You can see the silt buildup that happened during that rain event. Good job. And to this day, we have very functional tree planters that are functioning as inlets on this street. They're working great. Same project, different subcontractor. This subcontractor was not at the pre-construction meeting either, had a lot of communication issues. We were calling them to see when they were going to be out on site. We could never get a good schedule. And so this was not inspected as it was put in the ground. A lot of ponded water. We scraped off the aggregate that was on top. It was a landscaping aggregate on top. And we found a film. And what had happened is the aggregate was not clean. It was not double washed. And so all of that, those fines had washed down and accumulated on our growing layer, which is shown, the media layer, shown on the right-hand side. We just scraped that off, and the water went right down into the system. So you can see how just a small material issue can cause a big problem on a site. I think a big challenge, and this is a whole nother topic, is asset management. So Paul, you talked about this morning related to Metro. Cities are really struggling with this on the stormwater side, or I see a lot of cities struggling with this, even not knowing where all their inlets and pipes are to that degree. How are they going to know where our green infrastructure facilities are, our stormwater control measures, where it's at, who's taking care of it, how to take care of it, especially on our private facilities that maybe change hands. We need to think about better communication tools, I think globally, and education tools as well.
And so in wrapping up here with a few slides, we talked about this with the Walmart side. Interdisciplinary design teams, I think, are important to make these things look beautiful so they're a community benefit. Next slide. We can also have more innovative designs. The Kansas City Metro chapter of APWA has this. This is a conservation culvert on the left. So we can put back culverts more like Mother Nature. There's more, once again, there's more value in that. That's something we can be doing. We can start being more adaptive of integrating designs that integrate into the neighborhood instead of just being these ugly trash detention type facilities only.
And then we can also, I think, structure our solutions more on where they are at in the watershed. There's opportunities there. So think about our kind of larger, even more flood control facilities at the lower part of the watershed. Look at opportunities for more regional detention versus having detention on every development lot. Look at that in the middle part of our watersheds. And then really, really looking at the top of our watersheds. Is there places where we can capture that rainfall before we even get it to the system?
Right. And so just in closing here, you just bring these up. We were trying, like I mentioned at the beginning, really want to increase that value for the benefit of all. We want to design and build and think about that maintain for more resilient solutions. And Brenda had some great examples there. And then it really gets down to, what is that total price that you have, and including that maintenance. So all things just to think about. We touched on a lot of things here today, and I think we're only over Leaf by 30, 40 seconds, so we apologize. But thank you again for the opportunity.
Yes.
I found it really interesting, you talked about stacking benefits and watershed zones. I think it's something I think we all need to think about in Northwest Arkansas particularly. I think it's a real opportunity as we do urbanize and develop these, and I know a lot of in the room are actually already thinking about it, but really interesting presentation. Are there questions to Brenda or Andy?
We understand. We're in between you and lunch, so you can catch us over lunch for questions too. So.
Yeah, I could do that. Nothing online? Okay. No questions? You sure? Travis, thank you.
So I know y'all talk to lots of different groups. You talk to fellow engineers and city staff and planners. In the context that you've worked in the past, do you have a sense of which kind of stakeholder group that when you go and talk to them, you see the biggest change in getting in the good direction? Like where's that barrier where you get in front of this certain group of people and those doors open up and change happens? Is it kind of just an amalgamation of getting in front of everybody, or like, hey, once we get in front of the elected officials, then it happens? Once we get in front of city engineers, do you have any sense? Oh,
that's a loaded question. Great question, but loaded question, definitely. I think you have to do it at all the levels. I think it's that continuous communication, education. I think I am seeing a lot more, I'll call it kind of a sandwich approach right now. I see a lot of elected officials that are very supportive, so that's kind of that top down. And I see a lot of grassroots people that want to have these types of solutions, right? And what I find is our city engineers, our public works directors are in between. They're that sandwich. And I think they're feeling very stressed because they're getting it from both levels. So I think we need to be very cognizant of that and developing these tools to help those city, county folks that are implementing this, because they're feeling it from both sides. So I think that middle stakeholder group is important to think about. And I know those in the room that are feeling that. That's where we need to get those standards and tools updated so we can provide some of that ability for you guys to deal with that from those stakeholders, the grassroots people that want it, and your politicians that are saying do it. So that's important. But I think it's at all those levels. I think you need to be educating. So.
Yeah, I don't think the communication ever stops. I mean, we talk about going in and go talk to your city council every so often, or go talk to your neighborhood groups twice for the project. it needs to be continual and intentional.
And use the shredded wheat example. Maybe that'll help you.
Yeah. Any other questions? All right. Thank you, Brenda and Andy. Really appreciate it.